This is question 7 from September 2025 Mpumalanga paper 1. So we're going to do 7.1. So we are given f at x, which is equal to -4 over x, and we need to determine this from first principles. So we're going to start off with our equation, which is limit as h is approaching 0, f at x plus h minus f at x, and then we divide this by h. Then we substitute our given equation here. So you're going to keep the limit. So limit as h is approaching 0. You're going to have -4 over x plus h minus, now check, this equation is negative and our formula calls for a negative as well. So a negative by a negative, that's going to be plus 4 over x. All right, but you still have that h divided by h there. All right, now let's simplify our numerator on the side there. So you are having -4 x plus h plus 4 over x. So we take our LCD, which is x plus h, and then we're going to have -4x plus 4x plus 4h, right? Now the -4x here will get rid of this positive 4x, and that's going to give us what? 0 is our answer, so we have 4h. Then multiply out there, you have x squared plus xh. So now let's come back and substitute it like that. So this is going to be limit as h is approaching 0. So we're going to have 4h over x squared plus xh. But now remember, you're still dividing by what? By that h. Okay, now we're having a fraction over a fraction, right? So this is the same thing as saying limit as h is approaching 0, 4h over x squared plus xh. You know, when you're dividing fractions, you introduce multiplication and then you flip the second fraction. And what happens here is that this h will get rid of that h, right? So now what are we left with? We are left with limit as h is approaching 0. We have a numerator of 4 and a denominator of x squared plus xh. All right, now we can drop the limit. Why? Because we're going to be substituting our h as 0. So we're going to have 4 over x squared plus x into 0, which is the same thing as 4 over x squared. Now, if you wanted to be sure whether your derivative is correct, you can actually use what? The power rules, just to see if it's actually correct, right? But this is our derivative there. Now, let's go on to the next question. Next question, we are still deriving, but they didn't say using first principles. And since they didn't say using first principles, we're going to derive using our rules. So we're going to start with 7.2.1. So this is the equation given. I see brackets here and I see that this x is a denominator. So we need to fix that before we can derive. So we're going to have f at x is equal to, now fixing this x squared, what are you going to do? Make it to be a numerator. So there's going to be -5x to the power of -2. All right. Now this, we are multiplying it by what? By pi. And pi, remember, is a number. It's not a variable, right? So you're going to have plus 4 pi x, right? Multiplying out by pi minus pi. All right, now everything is set. We can now derive. So we're going to have f prime at x is equal to, now let's derive. The -2 is going to multiply the -5, which is going to be 10x. Now, after you've multiplied your coefficient by the exponent, you subtract 1 from the exponent. So from the -2, subtract 1, that's going to give you -3, right? Done. Now, here we have an exponent of 1. We use that 1 to multiply our 4 pi. You're not just multiplying 4, you're multiplying 4 pi, right? So 1 multiplied by 4 pi, that's still 4 pi. Now, 1 minus 1, that's going to give us what? 0. And anything to the power of 0, the answer is 1. Now, pi is a constant, and we know the derivative of a constant is 0. So now, this is our answer. We're going to leave it like this. Now, unless they state that leave your answer in positive exponents, then you can leave it with positive exponents, or you can go according to what your teacher has advised you to do, right? So I'm going to leave it like this. Okay, now 7.2.2, we need to determine the derivative. Again, this equation needs to be fixed, right? So now let's focus on that. So what do we have here? So you're having dx. Okay, so you're having dx. We need to fix this. So now fixing this, you're having a fourth root, right? So it's going to be x to the power of 3 divided by 4, right? And then minus 2x to the power of 5. And then that's divided by what? By x. Now we still need to further divide. So that's going to be dx. We're still fixing, right? Now you're going to be saying, remember the laws of exponents, x to the power of 3 over 4 divided by x. This is the same thing as saying x to the power of 3 over 4 minus 1, right? Because we take one base, subtract the exponent. So now this is going to give us negative 1 over 3 as our answer, right? So this is going to be x to the power of negative 1/3. Okay, you do the same thing with the 2x to the power of 5. So you're having 2x to the power of 5 divided by x. This is going to be 2x to the power of 5 minus 1. Okay, and then this is going to be 2x to the power of 4. So you're going to have minus 2x to the power of 4. All right, now we have fixed our equation, so we can now what? Derive. So this is when we are now going to write dx equal to, right? So now you're going to use this exponent of 1/3, negative 1/3, to multiply your coefficient of 1. That's going to give you what? Negative 1 over 3 still, right? X. And then now here, when you say negative 1 over 3 minus 1, that's going to give us negative 4 over 3. So you're going to have negative 4 over 3 there. So it's going to be x to the power of negative 4 over 3. All right, now we do the same thing with the 4. So we're going to have 4 multiplied by negative 2, which is going to give us what? A positive 8, negative 8, sorry. And then x, subtract 1 from the 4, that's going to be 4 minus 1, which is going to give us what? 3. Okay, so now this is now derived. Okay, so now let's look at 7.2.3. All right, so now let's look at 7.2.3. So the equation we're given, now it also needs to be fixed. So we're having y is equal to x squared minus x minus 6, and then x minus 3 to the power of negative 1. Now this bracket here, because it's a negative 1, we're going to have it as x squared minus x minus 6 divided by x minus 3, right? Now, if you check the numerator, it's a trinomial which we can factorize as x minus 3 and then x plus 2 divided by x minus 3. So now what happens here is that this x minus 3 gets rid of that x minus 3, and we are left with y is equal to x plus 2. Now the equation is fixed. We can now determine our derivative. So dy over dx is going to be equal to, we have an exponent of what? 1 over here, right? So it's going to multiply this exponent of 1 over there. So 1 by 1, that's actually going to give us what? 1, right? So we're going to be having 1 here. You subtract 1 from this, it's 0. So we just left with what? 1 as our final answer. I'm not going to consider 2 because it's a constant, and as you already know, the derivative of a constant is 0. So 1 is our final answer.